Hey, welcome to our seventh and final discussion of our visual system. This time we're talking about the dorsal stream. So the perception of movement is absolutely critical for most species. We just not only know what things are in our environment, we need to know where they are and where they're going. So some functional imaging work has shown us the motion sensitive area, V5, pictured right here, is found with the inferior temporal sulcus of the human brain. So V5 does a lot of really cool stuff. It allows us to smoothly perceive moving objects. So pouring a nice cup of morning coffee, you can see the fluid flowing into the cup. It also allows us to see optic flow, which is the relative movement between the observer and the environment. So if you imagine that you're walking down a hallway and maybe posters or windows or other objects on the walls are sort of moving past you as you're moving through that hallway, that's optic flow, right? Things in your environment moving past you as you are moving through them. V5 allows us to perceive that sense of optic flow. Damage to V5 can cause akinetopsia or motion. This is a really strange disorder that's really kind of hard to imagine, but it's the inability to perceive movement. People afflicted with akinetopsia or motion blindness basically see the world as a series of still images. So pouring coffee, they might describe it as looking like a sort of stationary brown icicle. And then the next bit of information they get is that their saucer has overflowed and coffee is spilled out. Likewise, watching a busy scene of traffic and people walking about, they might see people sort of jumping from space to space, but they don't perceive the smooth movement of them moving from place to place. They just sort of get chunked information. So we're pretty good at perceiving form and motion. And in fact, we can perceive form from motion. So even with some really bare bones information like this right here, we can tell a lot about what we're looking at and what it's doing. So the ventral posterior region of our temporal sulcus is really important for this type of perception. So I'm just going to play this little animation here and see if you can identify what this wireframe person is doing. So pretty interesting, right? Even with just bare bones dots, roughly in the shape of a humanoid form, we can get things like, oh, they're standing around, they're walking, they're throwing a ball. You can even get some stuff about maybe the emotional content, right? The person checking their watch seems bored. The person pushing might be in an aggressive situation. We're really good at getting a lot of information from not very much visual stimulation. So the intraparietal sulcus, or IPS, is the end of the dorsal stream of the visual association cortex. This is involved in the perception of location, visual attention, and control of eye and hand movement. So I'm not placing too much emphasis on the location of these regions in the brain, but if you're curious, you look at figure 6.2 here of a sort of inflated posterior parietal cortex, showing the anatomy of these various regions that we have discussed. So we really only hit the highlights of some of the more interesting regions in the interest of time. And you're not required to memorize this table by any means, but if you're curious about all the other different regions that we didn't spend much time talking about, here are just a selection of those and some of the functions that they perform. So with that, we'll conclude our discussion of the visual system. I'll see you next time.